All right. Hello. Welcome to CS61A, homework number 5, getting started. This problem we're going to be focusing on is stairways. So for this problem, we can think back to discussion 3 when we were using stairways to return a list of paths that we can go up the stairs taking either one or two steps at a time. In this problem, rather than returning those lists, we're instead going to be yielding all of these lists, in turn making a generator function. So let's first think about our recursive cases for this problem, and then we can go into a little bit how we can make this a generator. So if we think back to what we're trying to do with this problem, we can imagine, let's say n is equal to 3. This means that we have a staircase that is 3 steps tall, something like this. And our goal is to find all the paths that a person can take from the bottom of these stairs all the way up to the top by taking either one step or two steps at a time. Now, the way that we can think about this problem is similar to tree recursion in terms of the amount of paths that we can take up is similar to the option that we have at each step. So for example, if we're at the bottom of the staircase here, this is very similar to if we have two paths or two options. Either we take one step up the stairs, so we're now on the first step, or we take two steps up the stairs, and we're on the second step. So we can't really draw these diagrams in our code though, but we can represent them with numbers. So let's see how we might be able to do that. Well, if we think of n as the stairs that we need remaining to get up, then if we start with 3 stairs needed to get all the way up to the top, then taking one step is equivalent to only needing one less step to get up to. So that means we only need 2 steps to get up. And then if we took 2 steps in the first place, then we only have one more step to go. So our next path is going to look like one step. Now, with tree recursion, of course, that we can take this option for both the two-step or 2 stairs remaining and 1 stair remaining as well. So we can think about the options that we have here, either taking 1 step, 2 steps, and seeing what the remaining result is. So that's kind of what our recursive step might look like. Now, I'll leave the base cases up to you, but think about what it means to be done with going up the stairs and also what it means to maybe overshoot the amount of steps that we need to get. Okay, so now looking at the generator, we remember that in the original example, we could just return the total list of paths that we could take up to the top of the stairs. In this case, we can't return anything, but we can yield. So yielding is the way of creating our function to instead be a generator. And in this case, whenever we yield, we only want to yield one element of that returning list at a time. So if, for example, our list contained 3 options, so 1, 1, 1, 2, 1, and 1, 2, then somewhere in our code, we should be yielding each of these 3 paths individually. So rather than returning this entire list, we're just returning or yielding each of these 3 values separately. So think about how we might be able to do that with this kind of recursive example that we have here, because we know that all of the paths that work for this branch and all the paths that work for this branch can be modified to be branches that work for the entire tree. So how might we be able to do that given that we took 1 step going this way and 2 steps going that way? I'll leave that up to you to figure out. But other than that, we just have to know about our base cases and then have to make sure that for all of the possible branches in our trees, we modify them so that we can get the full solution for our main problem. All right, I hope that was helpful, and I wish you guys luck on this problem.